Next, let's talk about the rotation itself. We know that rotation has values for 3 axes. In Maya, among the values of the 3 axes, they also have a hierarchical relationship. By default, the z-axis is the topmost parent. Then comes the y-axis and then the x-axis. Of course, this order can be changed in Maya. For example, we can change it so y-axis is on top, then the x-axis, and then the z-axis. Or maybe the x-axis is on top, then the z-axis, and then the y-axis. It just depends on how you want to combine them. You can combine the 3 axes in different orders. This has a special name in Maya. This order is called the rotate order in Maya, and its written format is from bottom to top, meaning the child object is at the beginning and the parent object is at the end. So if we go with the default, z-axis is on top, then y-axis, then x-axis, that rotate order is xyz. And for the one we just mentioned, again in bottom to top order, that would be zxy, and this one would be yzx. In terms of function, it's also easy to understand. Using the default xyz as an example, that means z-axis is the parent of y-axis, and y-axis is the parent of x-axis. Let's go back to Maya. I've created a simple hierarchy here to help you understand how rotation actually works. Let's take a look. You can see I have 3 ring models here representing our x, y, and z axis. Look here, it's a hierarchy. Just as we analyzed, the z-axis is at the top level. So look here. When it rotates, our y-axis and x-axis as its children will follow. When we rotate the y-axis, we will see the x-axis follows. And then, when we rotate the x-axis, no other axis will follow because it's the child object at the very bottom. So, the hierarchical relationship between the x, y, and z axis is what we call the rotate order. If we change it, for example, let's change it to x, z, y. We read the rotate order from bottom to top. So, let's take a look now. When we rotate the y-axis, everything follows. Then when we rotate the z-axis, the x-axis follows. And when we rotate the x-axis, again, no other axis will follow. This is how rotation works in Maya. Let's create an object now to see how it actually runs in Maya. So let's select this object. You can take a look. For example, when I rotate the x-axis, and then I go to rotate its z-axis, you will see the same problem we had with translation appears here. It looks like I'm rotating on one axis of the manipulator. But in the channel box, the values for all 3 axes have changed. The principle here is pretty much the same as before. It's that our manipulator, the reason it's designed this way, is for our convenience when modeling or animating. It's not how Maya actually calculates things. If we want to see Maya's actual calculation method, it is the same. We can switch to the tool settings. Then, with the tool set to rotate, let's look at the axis orientation. Here we have object and world, and there's an option called Gimbal. This is how Maya's rotation actually operates. If you want to use a hotkey, it's similar. We press and hold E on the keyboard, then left click. And here you'll see we can switch back to object, switch to world, and here we can also press E and switch to Gimbal. Let's take a quick look. When we rotate the z-axis, it's just like the demo with the 3 ring models. When we rotate the z-axis, the y and x-axis follow. When we rotate the y-axis, only the x-axis follows. And when we rotate the x-axis, no other axis changes. We mentioned earlier that this hierarchy order can be changed. So how do we change it? You can change it in the attribute editor. Press Ctrl+A to open the attribute editor. Under the PCCube1 tab, we will see an attribute called rotate order. The default is XYZ. You can see all the combinations here. As we mentioned before, the order of this attribute is from child to parent. For example, if we switch to ZYX, we know the x-axis is the topmost parent, and the z-axis is the bottommost child. So let's try it out. When we rotate the x-axis, you'll see both of the other axes change. But when we rotate the z-axis, no other axis moves along with it. If we rotate the y-axis, only the z-axis moves along with it. So this is the concept of rotate order we were talking about. Let's switch it back to the default XYZ and zero this out. The next I want to look at is something you may have heard of called gimbal lock. This is actually a concept very easy to understand. As you know, our default rotate order is XYZ. So Z-axis is the top level. When we rotate the Y-axis, you'll see the X-axis follows. Look here, as we keep rotating, when we rotate to a 90-degree angle, I'll offset them slightly here so we can better see the difference between them. You will see here, my X-axis and Z-axis are now doing the same thing. And we no longer have any axis that can rotate in our original X-axis direction. This is what we call gimbal lock. Gimbal lock is an unavoidable thing in 3D. What we can do is try our best to hide it, to make this problem occur as little as possible. So how do we avoid gimbal lock as much as possible? The main way is to change the rotate order. Our basic approach to changing the rotate order is we need to analyze an object and find its most important rotation axis, then the second most important rotation axis, and finally our least important rotation axis. The most important rotation axis will be placed at the highest level in the parent's position. Then we take the second most important rotation axis and put it in the bottommost child's position. The axis in the middle is our least important rotation axis. Let's use a wrist as an example to analyze this. Let's assume the rotate order is the default XYZ. We know that in this case, our Z-axis is at the top level, then Y-axis, and then X-axis. So let's think about our wrist, what its movement is actually like. We know our wrist, first, it definitely has an up and down movement in this direction. And this range of motion is quite large. Basically, it can go from 90 degrees to 90 degrees. Then we have a sideways rotation, but this angle is very small. You can try it with your own wrist. It's very limited. And then we have another axis, which is our twist. This is when we rotate our wrist like this. If you take a look, it's rotating our wrist like this. This range of motion is also relatively large. If we were to define it, we would define this up and down axis as our primary axis, because the most important movement for our wrist is this one. So here we know this is our rotate Z. Then we know our sideways rotation is very limited. So this is our least important axis. We just mentioned the least important axis goes in the middle. So this axis is our rotate Y. And this twist along the wrist, this is our rotate X. Why do we have this kind of setup? First, the most important axis. This one is obvious. Because it's our most important axis, it acts as our highest level. This way, no matter what, its rotation won't be affected by any other axis. The reason we put our second most important axis at the bottom is because this way we can always extract a very clean rotation value. To give a simple example, when our wrist rotates sideways along this axis, our arm stays in the same position, but our hand will change. We've rotated our hand this way. Now look what happens when we try to do the twist again. Because in this case, our x-axis is the child of the y-axis. Our x-axis's rotation axis will also change, because it's its child, right? When the y-axis rotates, our x-axis coordinate system follows. This way, no matter how we rotate that middle axis, we can always get a complete twist value in the end. This is also why we put the second most important rotation axis at the very bottom. Rotate order and gimbal lock are things we will use often in our future rigging work. Don't worry, we will discuss them again and again later on, and modify our rotate order to help you all understand this concept. That's all for our more in-depth explanation of translate, rotate, and scale. I hope that through this section, you all have a better understanding of this topic. We will continue to apply these concepts in future chapters to help you understand them better. See you in the next video.